continuous hazard is G1. Intermediate hazard would be G2, and hazardous under abnormal conditions would be a G3. And then you also have safety categories for dusts would be D1 for a continuous hazard, a D2 for an intermediate hazard, and a hazardous under abnormal conditions would be a D3. So if you saw something that said G2, then you would know that that's a gas and it's a Div 1 location or Zone 1 location. There are various methods of protection recognized by the IC. For Zone 0, you can only protect it with intrinsic safety systems, and IA is the symbol for that. For Zones 1 and 2, there are different methods you can use to protect it. Intrinsic safety, IB, oil immersion, like an oil-filled transformer, an internal pressure surge, a P. So let's say if you had EXP, that means you've got an explosive environment that requires a P, or pressurized panel, and we'll talk about that in a minute. Then you have EXQ, EXM, EXE, or EXD, a flame-proof enclosure. And an EXD would be similar to a NEMA 7 box. For Zone 2 only, then you can use the concept N, which is like a terminal block. If you had like a NEMA 4 box, it didn't have to be NEMA 4, but if we did have a NEMA 4 box and we had terminal blocks in there, there's no arcing and sparking devices in that terminal, in that enclosure, so that would be equivalent to a EXN concept. The D and the E, these are the most common methods of protection in the world. Flame-proof D, increased safety E. Manufacturers manufacture electrical equipment in accordance with these two methods of protection. The flame-proof, the EXD, enclosure must be capable of withstanding the internal explosion. The increased safety, EXE, the apparatus which does not arc or spark or generate temperatures high enough to cause ignition in normal operation. Used for electrical terminations, motors, transformers, and lighting fixtures. A transformer has just coils. There's no arcing and sparking devices in it, and it could be classified as EXE. Your intrinsic safety, EXI, pressurization apparatus, EXP, oil immersion, EXO, powder filled apparatus, EXQ, non-sparking, EXN, restricted breathing enclosures, apparatus which does not spark or arc or spark or generate temperatures high enough to cause ignition in normal operation would be a non-sparking EXN enclosure. So we're going to go ahead and talk about, we'll lead into a little bit more about the EXP, but let's just talk about this explosion-proof box. So here you have your actual large crock box. It's a big, heavy-duty NEMA 7 box that has all the proper bolts on there, and inside that box is arcing and sparking devices such as relays, motor starters, etc. So the advantage is it contains the explosion, requires low maintenance. You can put high-powered equipment in there as long as it doesn't get the outside of the box over the auto-ignition temperature. It has no electronics, and it has no moving parts. So those are some good advantages. The disadvantages are you cannot indicate failure of containment capability. What that means is if somebody goes around there and loosens up all the bolts, you have no idea of knowing it. So if they put one bolt on there, you think you're all happy. You can put a door switch on there and stuff like that, but as long as they close the door and put one bolt, then you're good. So you have to actually inspect these boxes on a regular basis to make sure everybody has put the proper bolt in there. Don't let them just substitute that bolt. And two, they need to have all the bolts in there, and they need to be properly torqued down. So another disadvantage is danger to equipment after explosions. Obviously, the explosion occurs inside this box, and the internal equipment can be damaged from that explosion. Possibility of installation maintenance errors. Cost of protection per cubic foot increases with enclosure size. Well, that's true because these enclosures are limited in size. Usually they are about 3 foot tall, maybe 3 foot wide, and about 16 inches deep is about as maximum as you're going to get one of these. The windows are limited. You can actually put windows on these NEMA 7 enclosures, and there's only a limited amount of windows you can install. It does promote condensation because these boxes do breathe. They're very heavy, cumbersome, limited access, causes harmful heat buildup. That's true. Limited sizes, bulky design, and excessive weight. These boxes are heavy. So if you're installing one of these on a skidded application or you're planning on mounting one, make sure you get a structural or mechanical engineer involved to make sure that you design your the supports to hold this box in place, because this is a very, very heavy box. Here we have an intrinsically safe system. So here we have a device inside this enclosure that limits the actual energy so that you can never have an explosion. It actually limits the ability to create an arc. So the advantages are it's only protection allowed for zone 0, eliminates possibility of explosion, requires low maintenance, ideal for low power devices. You don't require a hot permit. No special cables, and you can actually install regular general purpose conduit installation, no seals or anything going into the hazardous area because you have limited the energy. So that's an advantage. It limits energy to the device. Disadvantages: requires documentation of IS circuit and installation. Can be only used with low power devices. Remember I said 2 watts is your limitation for hydrogen. If you're trying to start a large motor like a 25 horsepower motor, you're not going to be installing this on an IS barrier. These IS barriers are really limited for low like an on-off signal for a PLC, or like a little limit switch on a valve going to a DCS. They are also used for 4 to 20 milliamp signals. And then now we have the purge, the EXP. Well, in NEMA terms, we don't call them EXP. We call it a Z purge, a Y purge, or an X purge. And we'll talk about that a little bit here. But here we have a regular box, an enclosure, and this is not anything special. This particular one happens to be a NEMA 4X, so that means that they can have a spray in any direction, and it's corrosion resistant because it's stainless steel. And now here we have a regular PLC or different devices that are, in this case, you can see this enclosure right here is actually a NEMA 7 enclosure. We'll talk about that. So more than likely, this is a Y purge or even an X purge. Anyway, basically what happens is you flood this inside of this enclosure with instrument air or an inert gas from a safe area, and you prevent the gas from the atmosphere around it from getting inside the box. So you've cut off one of your 3 items that would require an explosion, right? If you had a flame or ignition source, oxygen, and then the fuel. So what you've done is you've cut off the fuel, so you can't get the fuel inside the ignition source. The advantages are it reduces heat buildup. That's debatable because I used to make large rectifiers, and I tried everything possible to reduce the heat sources or heat buildup, and this air contribution from one of these small purge systems rarely does that. But I guess any airflow is better than no airflow, right? So inhibits metal corrosion. That's true because you have a dry, clean source of fresh air blowing inside this box, and so you're not going to get condensation in this box, or you're not going to have the environment, the harshness of the environment around this box to get inside the enclosure. Requires low maintenance, increased equipment longevity. No special enclosures required. That's true. Allows fast access to equipment. Just pop the box open and you can get into it. Reduces moisture or dust buildup. That's true. Reduces classification within the enclosure. What this means is if you have a Class 1 Div 2 area outside of this enclosure, you put general purpose, just regular equipment inside, arcing and sparking devices inside this box, and you put a Z-purge on it, then you're okay. You've now have a enclosure that is suitable for a Class 1 Div 2 area. Continuous system status indication. You can actually walk up to it and see this gauge right here. You can see this gauge, and as long as it's in the green area, then you know you're good shape. There's also a pressure switch that gives you a dry contact back to your PLC or to a light inside your DCS room that tells you that your purge is satisfied. Protects enclosures up to 450 cubic foot. That's really large, and that is the biggest benefit. And of course, any of these enclosures can be of any shape. Cost of protection per foot cubic foot decreases with enclosure size. Typically, one of these actual purge systems run around, I don't know, $1,500 or something. And so if you have a really large box, you're going to actually cost a lot less per cubic, compared to your cubic foot size box. The disadvantages are it contains moving parts, it contains that switch and this gauge, requires instrument air supply, and it needs to be a dry, clean instrument air supply. Requires some electronics, and hot permits are required to open this box. Pressurization types. The NFPA and ISA defines types of pressurization based on the division, rating of the hazardous location, and electrical ratings of the protected equipment. General purpose and Division 2 rated electrical equipment require different means of protection depending on their location. A Type X protects general purpose equipment in Div 1 areas. So here you put a motor starter or some arcing sparking device in a regular NEMA 4 box, and you put a Type X purge on it, that will actually be legal. The only thing is you need to make sure before the purge is applied that all power is off of this device. So it does require some means of removing power from the box. The purges occur, and then it has 4 exchanges of air. It has a little timer built into an electronic device that counts the proper purges to make sure that you have proper flushing of all the gases out of the box. And then once that's been satisfied, it sends a signal back to your main contactor, which allows power to be applied. If you lose your purge on a Type X system, the power is immediately removed. A Type Y protects Div 2 rated equipment in a Div 1 location. If you look at some of these PLCs, you'll see that they're actually rated for Div 2 areas. That Div 2 PLC can actually be installed in a NEMA 4 box or a general purpose box and then put in a Div 1 area. And then by using a Type Y purge, then it'll actually reduce the actual enclosure itself so that it can be installed in a Div 1 area. You do not need to remove power for this, and it does require visual and audible alarms, and that must be initiated when there's a loss of pressure. The Type Z, which is probably the most common, protects general purpose equipment in Div 2 areas. So if you have a regular panel that you've been building all along forever, and you've decided to put it in a Div 2 area, if you install a proper purge, Type Z purge system, then you now have a Division 2 certified panel. So you're basically bringing a Div 2 to non-classified. You're actually putting non-classified equipment in this box, and you're allowed to put the box in a Div 2 area. Automatic power control disconnects are not required, but visual and audible alarms must be initiated when there is a loss of pressure. So a Type Z and a Type Y purge are almost identical, other than the equipment inside the box. For a Type Y box or Type Y purge, the equipment inside the box is Div 2 rated, and the entire enclosure is installed in a Div 1 location. For a Type Z box, the equipment inside the enclosure is general purpose, and you install the type Z purge, and now you have a device or an enclosure that's rated for a Div 2 area. The area classification determines the type of purge system needed. For Div 1 areas, the equipment inside the enclosure determines whether a Type X system, equipment rated for general purpose, or a Type Y system, equipment rated for Div 2, can be used. We just discussed that. So here we have a little diagram. We have the protective gas heading in here. We've got a pressure regulator. We have our protected enclosure with a relief valve or relief vent. We have pressure indication, and then we have our optional alarm or power cut off switch. So here you can see this is a Type Y or Z. So this one device can be used as a Type Y or Z device. You've got your local indication, so you know if it's in the safe area. You've got the proper pressure of air, and then you've got your regulator right here, and you can adjust how much air is flowing into it. If you are installing a Z purge or Y purge on a single enclosure, so here you have your protected enclosure. You've got your supply. You want to come in the bottom, and then you want to vent from the top, and then you've got your indication out here. A lot of times with this, some people will put a general purpose switch inside the back of on the back pan of the panel. So general recommendations: the pressure system should be located immediately adjacent to the protected enclosures when possible. The pressurizing system should be installed at eye level in a prominent location for convenient viewing. No valve should be installed between the pressurizing system and the protected enclosures. The reference connection from the protected enclosure should be installed in a location which is not directly affected by airflow through the protected enclosures. All tubing, piping, and connection fittings should be suitable for the location in which they are installed and should be protected against mechanical damage. So those are the general recommendations when installing a purge system on a single enclosure. If you have multiple enclosures, you start with the smallest enclosure first. You have the pressurized system come in the bottom, come out of the top, come through the bottom, come out of the top, through the bottom. Out of the largest enclosure, you've got your relief device here, and then you've got your alarm indication or cutoff switch heading in this direction. So here you have protected enclosures should be connected from the smallest to the largest enclosure in series. Connections should be sized to allow proper operation of the pressurization system. Conduit or wireways may be utilized as protected enclosures or as connections between protected enclosures. All pressurized conduit and wireways should be sized to allow proper protective gas flow through the protected enclosures. The NFPA, National Fire Protection Association, recognizes the use of electrical conduit or wireways as a part of an approved system. The NFPA term approved system refers to a complete purged assembly that has been approved by an authority having jurisdiction. So when you create these different situations, you want to have an OSHA approved NRTL, nationally recognized testing laboratory, come in and certify your installation. And then here we have a protected enclosure. This is a purge protected enclosure, and we have a pressurized wireway to an adjacent pressurized device. It doesn't require a seal. Independently pressurized device here. So this one actually is part of this system, so you don't need the seal because it's a pressurized wireway. But if you have an independent system here and an independent system here, then you need two seals, one within 18 inches of each system. If you use intrinsically safe or fiber optical devices, then you just have a cable gland fitting and cable. If you have an intrinsically safe system or fiber optic device here, and you have a purge panel here, then you need a conduit seal here. If you have an explosion-proof device here and a purge panel here, so here you have a NEMA 7 box, and here let's say you have a NEMA 4 box with a Z purge, then you want to have a conduit seal between the two of them. What about the NEC Zone 1 and Zone 2? Zone 1, again, is similar to Div 1, excluding those areas defined as Zone 0, atmospheres containing flammable gases and vapors in ignitable concentrations under normal operating conditions. Zone 2 requirements will essentially remain the same as Div 2. So does that mean that if I have a piece of equipment rated for Div 2, can I install it in a Zone 2 area? The answer is no. You can only install a Zone 2 rated device in a Div 2 area. You cannot install a Div 2 device in a Zone 2 area. I don't understand that one, but that's the way the code's written. Group classification, NEC Article 505. Again, the Group 2C, atmospheres containing acetylene, hydrogen, or gases of vapors and equivalent hazard. This grouping is equivalent to Gas 1 Groups A and B as described in Sections 500.6A 1, 2. Group 2B, atmospheres containing different gases, ethylene, or gases of or vapors of equivalent hazard. This grouping is equivalent to Class 1 Group C as described in Section 500.6A3. And then Group 2A, atmospheres containing acetone, ammonia, ethyl, alcohol, gasoline, methane, propane, or gases of vapors of equivalent hazard. This grouping is equivalent to Class 1 Group D, as described in Section 500.6A4 of the National Electrical Code. Manufacturing standards. There's 3 main manufacturing standards throughout the world. You have IEC, Senelec, and the UL-FM American Laboratories. IEC, International Electrotechnical Commission, established in 1904. Most countries throughout the world accept the IEC standards. IEC standards 79.0 and 79.9. So it goes from, actually it's 60079.0 to 60079.9. Design of electrical equipment for hazardous zones. You also have IEC standards 79.10, classification of hazardous zones, and IEC standards 79.14, installation rules. The Senelec, the European Electrotechnical Standardized Committee, created in 1978 to harmonize standards throughout Europe. Starting point IEC standards only deals with manufacturing standards, no zone classification or installation rules. Compulsory standard in the Senelec member states. So what this means is if you're a manufacturer and you're designing equipment, you're a manufacturer of equipment and you're trying to ship it to the European states, you must have a CE label if it's a general purpose panel. You must have an ATEX rating if it's for a hazardous panel. And then again, you can self-certify CE for general purpose. You can self-certify Zone 2 panels, but you must have a notified third-party, approved third-party body from Senelec that can certify Zone 1 or Zone 2 panels. And those would have to be someone like TUV or BASIFA. Okay, let's talk about examples of classification of locations. So here we have a tank, and it's full of a liquid. It's a storage tank. And these, you can see these hash marks right here is a Div 1 area. And then we have a vent, and a 3 meter or 10 foot diameter around that would be a Div 1 area. And then a 1.5 meter or 5 foot diameter around that would be a Div 2 area. And so here you would have, this is your grade right here, you know. And if you were looking at a area classification map, this is the kind of this is the kind of hash marks you would see. There would be a little area that said this little mark right here means Div 1, and these little marks right here mean Div 2. And if it's non-classified, there would be no marks on it at all. This is per API 500. And this is Figure 50, flammable gas protected, blanketed and produced water handling equipment in non-enclosed, adequately ventilated area. So this tank is in an adequately ventilated area. So here's an IEC version of the same type of tank. So here you have the liquid. And then above that, they've put circles here, and that's a zone 0 area. And then we have the vented area, and we have a little area here, A, which is 3 meters from vent openings, and that would be a zone 1 area. And then around the tank, from the bottom all the way up to around the tops and all the way around to the bottom, would be a zone 2 area. And here we have a sump below grade. That sump is a zone 1 area. That sump in a API 500 area or an NEC location would also be a Div 1 area. Okay, this shows a process equipment vent in a non-enclosed, adequately ventilated area. So here we have a vent line that goes all the way up, and it's venting some gas. 3 meters or 10-foot diameter would be your Div 2 area, and then 1.5 or 5 feet around that device would be your Div 1 area. And then they go ahead and say the interior of the vent piping is a Div 1 area. Cross-hatching has been omitted for drawing clarity. So the gas is actually flowing up to a safe area. This is quite common. People will vent to a safe area, but now that you've vented this gas to a safe area, you've actually created a hazardous area around the top, around the vent opening. And here's the IEC equivalent of the same type of situation. They've got a vent. They vented it so, a matter of 25 feet up in the air or so. And they have a zone 1 and zone 2 area. Same idea. Okay, so here we have a source. This is a leak source, let's say. And we've got this in an adequately ventilated compressor shelter with lighter than air gas of vapor source. So here, this is API 500, straight out of API 500. You've got the actual enclosure here, or the actual space around it, is a Div 2 area. And we have a Div 2 area around the top of it. Remember, this is lighter than air gas or vapor source. So this whole area inside here is a Div 2 area. And then down here at grade, we have a, if there was a sump area, you'd have a Div 1 area. But if there's no sump, then you don't have a Div 1 area. And then this is the IEC equivalent of that. Again, you have your source right here, your compressor at the level. And then you have A from here to here would be 3 meters horizontal from source of release. So if this room is much larger than that, then you would just have a 3 meter diameter around that compressor level, and then you have a zone 2 area above it, all the way to the vented area. Here's a tank car, and this is a flammable liquid. So they have the actual vent here at the top, or where they pump the liquid into it. So here we have a below the sump area, we have a Div 1 area, we have grade here, then we have Div 2 area all the way around it, and then around the actual liquid transfer line, we have a Div 1 area again. So here, this kind of presents a problem, because a rail car full of gasoline or something would be a moving hazardous area. And then here's an IEC cargo load, like a truck, a gasoline truck or something like that, and they're actually going to fill this area right here. So here you have a drainage channel, would be a zone 1 area. All this area right here, so you have some area above that, all the way to here, all the way over here, would all be a zone 2 area, and then this area right here would all be a zone 1 area. So you can look at that this A dimension right here, from here to here, would be 1.5 meters horizontal from source of release. The B area would be from here to this area right here, would be 1.5 meters horizontal from flexible joint. The C area from the top of the tank, the truck, to this area right here would be above the source of release. And then D, the D area would be the height above grade, would be 1 meter above grade level. And then E E is right from the actual area here to here would be 4.5 meters horizontal from drainage channel to gantry, and then F would be from here to here, 1.5 meters horizontal from zone 1, and then G finally is from here to here, which is 1.0 meter above zone 1. So that's how IEC would